So could you please confirm whether you can see the slide?
Yes, sir.
Yes, sir.
Yes. Okay.
Yeah,
Thank you.
it is visible, sir.
It's visible. Okay. Thanks. And thanks for the introduction. And I just have included a few slides about my brief profile. So after returning back from Europe, I have started a company, Vision Corp Research and Development, where we primarily focus on biometrics and computer vision commercial research development. So that's what we are currently working on. And I also come as a resource person to many of the workshops and faculty development programs previously, particularly giving lectures in machine learning, classical machine learning and deep learning techniques. So before starting this company, I finished my postdoc through a Marie Curie Fellowship from Dublin City University in Ireland. And prior to that, I finished my PhD in computer science from Autonomous University of Madrid, Spain, and that was also through a Marie Curie Fellowship. And while pursuing my doctoral research work, I also worked as visiting researcher at Halmstad University in Sweden, and also as a visiting researcher at University of Twente in Netherlands. So throughout my research career, so I have been closely associated with 4 research labs in Europe. I graduated from Chennai Mathematical Institute. So this is my brief profile that I would like to introduce. So now this session is primarily focusing on the data visualization concept. So you'll just have a quick overview about that, and then I will introduce about how we can actually do some hands-on part as well. So just to cover up the context, so you'll have a small brief discussion about the importance of data visualizations and so forth. What are the tools that we will be using, and then we will look at how to use those things. And this particular slide I will be sharing. So I will. So after finishing this session, I will tell you from where you can download these slides. So coming to AI organizations, just briefly, let me introduce at what industry revolution we are at. So the industry revolution 1.0, it started in the 18th century. That was more about this mechanized production, especially you can say about steam engines or anything based on steam powered revolution was the one which happened in 18th century. So we call that as industry revolution 1.0. And the industry revolution 2.0 happened in the early 20th century. So that was more about electricity and related revolution in industry. So that is also related with mass production. In the late 20th century, we were at the industry revolution 3.0. That was more dominated by information technology, electronics and information technology per se. And currently, in the early 21st century, we are at Industry Revolution 4.0, and it is more about automation and data exchange. So this is where the artificial intelligence is playing a major role in this particular Industry Revolution 4.0. And we are in the beginning of that particular revolution, where artificial intelligence is going to play a dominant role. So coming to artificial intelligence, so we can ask the question, what is artificial intelligence? The very brief way of capturing the idea behind artificial intelligence is that there are applications that are especially targeted at automating tasks that we humans are good at. So that's what essentially artificial intelligence captures. So they are just applications. So these applications can be only a software-based application, or it can also be augmented with a hardware. So that's where we talk about robotics and so forth. So that is also a level of artificial intelligence. But even without any hardware, like mechanical parts, we can still have artificial intelligence only as part of a software. So this is essentially captured as artificial intelligence. They are applications. And we talk about machine learning and so forth. So machine learnings are the tools that are used to build these artificial intelligence. So any application that tries to automate the tasks of humans. And the most prominent domains where artificial intelligence pioneers is with visual processing. So you can say about computer vision domain and language processing. So that's about natural language processing that will comprise both text processing as well as speech processing. So these are the dominant domains. So we take any AI application, it will involve any of these domains. And we humans are also especially good at visual perception as well as learning or hearing and understanding. So that's what AI is trying to achieve, trying to automate the task. But when we look at industries pioneering in artificial intelligence, they will be especially in two specific domains. So artificial intelligence companies might be focusing on data science, and there will be companies that is focusing on machine learning. This particular session is being primarily focused at data science. The entire ATAL workshop is focused on data science. So many people might have been thinking, okay, what is data science and what is the difference between machine learning and data science per se? But data science definitely involves machine learning as its core. But as from the point of view of industries, for example, so the companies which are focusing on data science and companies which are focusing on machine learning differs in a slightly different way. So in both, whenever we talk about artificial intelligence in the current scenario, data plays an important role. So without data, we cannot actually achieve the kind of artificial intelligence that we are looking at. So data plays a crucial role in artificial intelligence. And even when we take the data science or machine learning, data plays an important role. So what especially data science does is that, collecting and analyzing data is a core part. And the companies which focuses on data science especially helps in improving the business. So they try to analyze the data and then make suggestions about how a company should progress, in which direction a company should progress, so that they will maximize their business and so forth. So those sort of recommendations are especially done by the domain of data science. But when it comes to machine learning, so what companies focusing on machine learning does, so they also collect data, analyzes it, and the important difference is that these machine learning companies deploy the models, the machine learning models that we talk about. So that becomes an integral part of a application, which essentially focuses on automating tasks. So where that could eventually lead to decrease in the operational cost of the running of the company and so forth. So that is how data science and machine learning are different. But data science will definitely involve machine learning concepts to make those decisions. But the data science is not specifically interested in automating tasks or deploying tasks and so forth. So that is more about the engineering aspect, and that is what machine learning especially captures. So now within an AI company, so what are the various project development life cycles and the various roles that is taken up? So let us have a brief look at that, and then we will get into the data visualization part. So companies with AI infrastructure, so what are the various modules that a company which takes up an AI project, so that what are the various modules that becomes an integral part? So there is a data engineering module or an aspect, we can say. So there will be a team who focuses on data engineering aspects. So that especially does data analysis. So the tools that are most commonly used, so let us say, for example, database tools, or there are some programming languages that are very essential in terms of performing this data engineering. And it also deals with handling humongous data sets. So that's, we call that as big data analytics. So these all are handled within the data engineering department. So next to that, there is a modeling team, so who focuses on collecting, taking this data, analyzing it, and then building some machine learning models on top of it. So the team with modeling is more interested in coming up with innovative machine learning models that can essentially be useful in decision making, or it could be used for automating the task. So these are some skills that are essentially required in terms of the modeling skills. It's about the mathematical understandings, the data science and machine learning skills. So these two are an integral part, and then comes the deployment. So once we have trained the model, then how do we deploy it? So whether we deploy it on a cloud server, or whether we deploy it on a mobile phone, whether we deploy it on some IoT devices like Raspberry Pi or the Jetson Nano, for example. So, or do we need to have it as a web-based machine learning application and so forth? So that is especially handled by the deployment team. So once we have this data engineering, modeling, and deployment, which essentially covers the core part of the AI infrastructure, then from the business point of view, there is also a business analysis team whose main focus is with communicating about these applications to the wide open market. So this is what essentially captured from a company point of view. Even say if you are from an academic point of view, the only thing we might not be interested in is with the business analysis, but where we wanted to actually market something. But the data engineering, modeling, and the deployment is also an integral part when you take up any academic research project. Even say, for example, if you are doing a PhD, where machine learning is the core tool that you are using. So you will be using up all these three modules as part of your work. And these are the essential skills that will be an integral requirement. So when we look at the AI teams and roles, we would have heard about these terminologies like or positions like data scientist role. So there is an open position as a data scientist and so forth. Or we will hear it like, okay, there is an open position for data analyst, or as a software engineer in the AI domain, or software engineering with machine learning focus, a machine learning engineer, a machine learning researcher. So these are certain types of artificial intelligence job profiles that we quite often encounter. So how does individual roles differ from each other based on whatever the AI infrastructure models we saw? So recently, Stanford University's a spin-out endeavor. So they conducted a census with many of the AI companies particularly in US, many big profile companies pioneering in artificial intelligence like Google, Microsoft, Facebook, Apple, and so forth. And then they tried to come up with a generic understanding about what are the tasks that these various roles, the people who are employed in these various roles, especially do. So when we divide our the entire AI infrastructure into data engineering, modeling, deployment, and business analysis. So let us see what are those different roles captures, how they capture these different modules of an AI infrastructure. So when we call someone as a data or someone working in a data scientist profile, so what they will be mostly engaged with is they will be doing this data engineering, they will be involved with the modeling, and they are more interested with the business analysis part. So they are not, mostly data scientists do not involved with the deployment aspect. So how this software or the model that we build need to be deployed into a mobile phone or a cloud-based server and so forth. A machine learning engineer, on the other hand, so it focuses on the data engineering, modeling, and deployment aspects and does not involve with the business analysis part. So when we take a data analyst, the data analyst part is more involved with the data engineering aspect and the business analysis aspect. So never into modeling or deployment aspects. So that's what mainly the data analysts do. And we can also see that many data analyst tasks are also performed by not with engineering background, but people who are, say, for example, who are into business administration. So people who study with MBA degrees and so forth. So for them, these data analysis skills is a very important aspect. A software engineer focusing on the machine learning. So there, the modeling aspect there is not an integral part, but the main part is with the data engineering and the deployment. And when we talk about machine learning researchers, so they are mostly involved with processing the data and coming up with new models so that can solve or address the challenges in a specific problem that they are interested in. So this you can see, like mostly people with PhD degrees, so they mostly work as these machine learning researchers in this job, focusing on that. And a software engineer mostly will be involved with the data engineering. So this is the general understanding based on the statistics from many of the high-profile companies working in the AI domain. So this is how different roles are distinguished, essentially. I think these distinctions will be helpful for us to even understand what are the various infrastructures and how important. So when you apply for or when you are working in a specific profile, so what are the various aspects that are of importance. So so this is the generic introduction I would like to mention. So coming to the tools or the environment to do these sort of machine learning in general, so anything related with machine learning. So the most prominent environment is called Conda. So this is a scientific, virtual scientific environment within which you can have multiple versions of libraries installed and so forth. It's a very useful environment. To get this Conda environment, you can either install it using an utility called Mini-Conda, or that can be also achieved using an utility called Anaconda. So these are the two different variants to get these scientific environment. And this is the most prominent scientific environment used in the domain of artificial intelligence. And many times we see that installing from Anaconda is a bit easier, but one of the downside is that Anaconda is too heavy. So it comes with a lot of modules pre-installed. It takes up a lot of space. The better alternative is that you can go for a Mini-Conda installation, so that will give only a minimal installation, and it is left to us what all scientific libraries that we are interested in, so we have to explicitly install it. And I would prefer Mini-Conda as the best option because it gives us the flexibility to what all libraries we need, so we can only install those things, not to have a lot of things installed and we never use that. So this is the hardcore environment where we have access to all the important scientific libraries. So within Conda, you can have multiple virtual environments and you can install different versions of the libraries as well. So that's one advantage. And the IDE, so this is the hardcore library platform, and the IDE that is more popular in this domain is called the Jupyter environment. So Jupyter is a web browser-based IDE which connects to all the libraries that we have in the Conda environment. So this is one of the most popular environment. So if you wanted to actually perform experiments or pursue your research works and all your data is in your local machines, and if you wanted to conduct experiments in your own computers or in your lab, so this is the best way. So you have to get the Conda through the Mini-Conda installation and use Jupyter as your IDE. But there is a lot of things that you needed to know, what are the libraries to install and so forth. So sometimes configuring that in Windows can be a bit of a headache because I have seen that many times there are some path conflicts. But with Linux, it is very well integrated. It installs very neatly and there are no confusions and so forth. But if you wanted to avoid all those hardware to configure and install it in your machine, then there is a better alternative to this entire combination of the Conda and Jupyter. So that is called Google Colab. So Colab stands for collaboratory. So this is a free platform, scientific computing platform provided by Google. If you have a Gmail account, then definitely we can use the Google Colab environment as well. So next to this, so we will be doing some hands-on. So I will be showing the code explanations and some visualizations that we can do in Google Colab. So this is a very important tool. So instead of configuring all these things, so you can straight away use Google Colab. You can log into Google Colab and run your experiments. So I will tell you how to run experiments and what are the various options available in Google Colab and so forth. The one of the advantages that Google Colab, it is a cloud-based service. It's a free service. In US, they have a paid version of Google Colab, but other than in US, they haven't started yet the paid version. But they have promised that there will always be a free version of Google Colab. So we can always use that for educational purpose. So one of the advantage with Google Colab is that we have free access to GPU. So GPU is the a graphical processing unit, which is specifically useful when we are doing computer vision based experiments. So it takes up a lot of resources, and if you have GPU access, the experiments will run a bit faster. Your training and inference experiments will run a bit faster. So if you are doing computer vision based experiment, and Google has come up with their own high intense cloud platform, high computing cloud platform with their own architecture called TPU. So TPU stands for Tensor Processing Unit. And in Google Colab, they have also given that option to access Tensor Processing Unit. So I will tell you how to access the free versions of the GPU as well as the TPU in Google Colab, so that it will be an introduction to Google Colab for you as well. So for later sessions that you'll be getting into machine learning, so regression, classification, and so forth, the supervised and unsupervised learning. So all of those things can be experimented in Google Colab. So I highly recommend Google Colab as an initial tool for everyone to start looking at. So this is going to be our environment, scientific environment for our discussions further. And there are a couple of libraries. So this is mainly based on Python. So Python is the most popular programming language in the domain of artificial intelligence as of now. And even when we look at the popularity of Python, so worldwide popularity, Python is in rank 3. So that's the status of Python. And the number 1 is currently the C programming language. The C programming language is ranked number 1 as of now. It will be a bit surprising because C programming language is such an old programming language, but it is still surprising to see how it is still standing at number 1. And at number 2 is Java, and then comes Python. So previously, Java used to be number 1 for several years, but now from this year, you can see the trend is slightly changing. So now C is becoming popular, Python is becoming popular, and Java is becoming less popular nowadays. So coming to Python-based environment, so there is a library, a Python-based library called Pandas, so which is the most popular library for data analysis. And even we are going to look at how we can use the Pandas library for certain data processing. But this is a very inevitable tool. So anyone getting into artificial intelligence research, so this is a very useful tool. And Pandas stands for panel data structures. That's the so this is a short form for panel data structure. So there are 3 prominent data structures when Pandas was introduced. This data analytics library was introduced. So the data structures were called series, data frames, and panels. And the recent versions of Pandas do not contain the panel data structure. It only contains series and data frame. These are the two prominent data structures. Our focus is mainly, this session is more focused on data visualization. So we can't get into detailed discussion about what series and data frames are. We cannot run an entire session on pandas as of now due to a time limitation. But I just wanted to let you know that this data frame is an important data structure in pandas that will be most prominently used. Series, you can think of it like it is a one-dimensional data structure, something like a vector. You can think in mind, or one-dimensional array sort of thing. And the data frame, you can think of it like a two-dimensional array, but it is not specifically two-dimensional array, but it is much more powerful than a two-dimensional array. But the important thing to keep in mind is that data frame is a two-dimensional data structure, and series is an one-dimensional data structure. And to be more specific, data frame is interpreted as a collection of series. So collection of one-dimensional data structures become the data frame, which is a two-dimensional data structure. So this is an important library that we will use. And secondly, for data visualization, we'll use a library called Seaborn. And so these pandas and Seaborn is going to be the most important libraries to use. So this is built on top of a base visualization library called Matplotlib. So this is the fundamental visualization library in Python. And Seaborn is, you can think of it like it is the look and feel of the visualization library is being enhanced using Seaborn. And now Seaborn is becoming more popular in terms of data visualization in general. So our discussion today is going to focus on Seaborn, and it provides a very high-level interface for generating visualizations, and it is very well integrated with the pandas data structure that we have discussed previously. So that is the Seaborn visualization library, which we will look at. It will be interesting to see that all the names are very interesting. The Python, pandas, Seaborn, and so forth, and it all seems like some animal names. But when we dig deep into what is the motivation behind all these names, you can even think of like the Python. So that the developer Guido van Rossum, so he named it after one of his favorite British comedy TV show series called Monty Python. So he was a big fan of that. So that's why he named the programming language after that TV series name, Monty Python. He just named it as Python. So these pandas, you can see it is also something, the name is related with panel data structure. So this panel is a data structure that is most prominently used in statistics. So statisticians use a tabular data structure, which they call it as panel. And a data structure, a computational version of this panel is the panel data structure. But unfortunately, the pandas team has decided to remove the panel name, the name panel from this data structure now. And the functionality of panel. So we said like series is a one-dimensional data structure, data frame is a two-dimensional data structure, and actually panel is assumed, is considered to be a three-dimensional data structure. But that, since that is very least used in the machine learning community, so they integrated the functionality, they extended data frame. If you need to handle some three-dimensional data structure, then data frame can also accommodate that. So that's how they are currently maintaining only these two data structures and discarded this. And the name Seaborn, when you dig into it, so it is also the developer. So he was also a fan of another TV show called The West Wings. So that is some US-based TV show. And from there, the Seaborn is part of one of the characters' name. So based on that, he named it as Seaborn as well. So those are some interesting side notes related with it. So just to have a quick access. So today we are going to deal with the Google Colab. So the source code for the Google Colab hands-on part that we are going to look at for the visualization. So that is, I will be sharing that as well together with this particular slide. So what you have to do is you have to go to this visioncog.com website. So if you go to that website, you click on these news and events, and you can locate for this data visualization and business intelligence, this Aligarh Muslim University, Uttar Pradesh. So you will, it will navigate to this particular page. So I will be conducting the session for business intelligence on 30th, so that day you will have those files as well to download. So you can download these two, the slides as well as the IPython notebook from this particular page zip file. So if you have a doubt, so let me just show you. So you can open a page. So you can simply search for VisionCog as well, VisionCog. So you can go to that VisionCog's website, and then you click on these news and events. You can click on anywhere. So you can just click on this particular part. It will navigate to this page, news and events. So you just go under this current. So these all are my previous sessions that I have conducted. So you can just go to the current. I can click on this particular page. So that will take you to this particular place where you can download these details. So you can just click on that. So then it will ask you where to save it. So you can just save it wherever you want. So now we can just go to temp, and so there will be, so I have saved it inside the temp. I'm using a Linux environment. So depending on your, wherever you are saving it, you can just go there. You can right click and extract it. So you will have these folder called AMU_session_03. So that's going to be the folder name. So I'll just zoom a little bit. So inside that you can see the PDF file, as well as there will be a file with the extension IPYNP. So let me show you that. So there will be a file extension, data visualization lab.ipynp. So you can, so this is what we are going to look at. So this file, we need to open it in Google Colab. So could you please confirm anyone was able to download and extract it, whether it works fine? And go to VisionCog website and then
yes, I have downloaded it and extracted it to my own folder.
Yeah, so everything is fine, right?
Yes, it's fine.
Yes, yeah, okay, thanks. So now what I would like to show you is how we can open these IPython notebook files. So we cannot simply double click and open it locally unless you have installed Jupyter application. You will not be able to open it here. But let us see how we can access this source code in Google Colab and how we can actually work in Google Colab. So the easiest way is that you open your Google Drive. So I'm showing my Google. So let me just zoom it a little bit so that it will be easier for you to look at. So just open your Google Drive. So here is my Google Drive. So let me right click here and create a new folder. Let me just call it as AMU. I'll just name it as AMU. And now what you have to do is you go inside that AMU, you navigate inside that. Here you can upload the file. So here what you can do is you click on the upload files option, and then you navigate to the folder where you have extracted it. So this AMU session 3 is where I have this IPython notebook file. So you have to select the IPython IPYNB file. So you click that and then you open it. So what it will do is it will upload that file, and you will be able to see the IPython notebook in this particular folder. See, so now you can see this data visualization _lab.ipython notebook. You can close this. So now this is the file that we needed to open. So what you have to do is you can right click on that, and then you can select open with Google Collaboratory. It will show this option. If for some reason, when you right click and when you go to open with, if it didn't show Google Colab here, then you have to, since I have already installed it in my Google Drive, so it already shows it. If it doesn't show to you, then what you have to do is you have to click on this, connect more apps, so it will open up an interface. And in that interface, you can search for Colab. You can search for Collaboratory. If it is not installed, so you have to install it. You have to click and install it. For me, it already says it is installed. If it is not, then you will have to click and install it. So once you have installed it, then when you right click on that, you can open with Google Colab. So when you just click on it, it will open up in Google Colab. So the link URL will start like collab.research.google.com. So that's how it will start. And this is the IPython file that we have opened it now. So this is how you will open it. Alternatively, if your task is not to upload and open any file, but you wanted to simply start some Google Colab environment, then what you can do is you can simply search for Google Colab, and you will have a Google Colab page. That also you can do. So you can simply click on it. If you wanted to start any IPython notebook, you can select that. Otherwise, you can just discard it here. So this is where this is the starting page of Google Colab. And here you can see many instructions given, so a small tutorial given and so forth. From here, you can start a new notebook. So all these interfaces are called notebook files. And IPynb stands for IPython notebook. So the file extension we see here is IPynb. So that stands for IPython notebook. When you start a new file, it starts with this untitled one.ipynb. So there will not be any name. So you can give any name you want here. So let us say, so I just call it like test.ipynb. So I just open it here. And now what you have to do is you can simply, to obtain the session, you can click on the connect button. So once you click on it, it will connect. And what happens is that Google is allocating a cloud session to you. So once a cloud session has been allocated, you will see a green tick mark here, and it will tell you how much of the RAM and disk space has been allocated in the Google Cloud session. So this RAM and disk space is from the Google's Cloud session, not from your local computer. So this has already connected to the Google Cloud. If you can click on this folder view here, so it will also show you in the current session which has been opened to you, there is a default folder called sample_data. You can click that, so you can also see some files that are there inside sample_data. So every time you start this session, this sample_data comes as default for your session. And whenever you have these Colab interface started, which you call it as IPython notebook. That is how we refer to it, as IPython notebook. We have two types of cells. So that is what we call it as a coding cell or a text cell. There are two types of cells. In the coding cell, we will enter all the Python statements to execute, and in the text cell we can include documentations, for example. Say for example, let me just call x is equal to, so this is a coding cell. By default, you will have a coding cell. So let me just take x is equal to 5, y is equal to 10, for example. And then I'm just print I'll just say z is equal to, then I will just do x plus y. So to execute this particular cell, you will have to either click on this play button here, or you can use Shift Enter. then you can see immediately below, you can see the result. So whatever has been executed at this particular place, you can, if you have some print statements, you can see the result immediately below it. So this is, so what you have to do is you have to press Shift plus Enter key. So when you do this combination, Shift plus Enter, you can, through key combination, you can execute it. So whatever variables defined in the cells above, it is also visible here. So if we say, for example, if we print X here and run it, so you have access to X as well. So whatever is defined in the previous cell, you have access to that in any of the cells that you are defining. So it is sort of a global visibility for all the cells. So the cells can communicate with each other. And the purpose of the text cell is that, say for example, if you wanted to, say for example, you can bring your mouse pointer towards this. So if you want to insert a text cell, you can insert a text cell, it will show it like this. So anything which starts with a single hash, it is called the first level heading. So you can immediately see a preview on the right hand side. So here goes some text, or whatever you want, you can type in there. And if you start with double hash, it is your second level heading. So the number of hash defines the level of the heading. So you can see there is a small difference between the font size and so forth. So this is how, with the number of hashes followed by a blank space. So there should be a blank space, and then you can define different. So this is like sections, subsections, and so forth. So that's what essentially defined using hash. And it also, if you are familiar with the LaTeX typesetting, so it also, you can also encapsulate mathematical equations inside that as well. So what it will do is it will immediately show the preview here as well. So say if you wanted to define a sigmoid function, then you can just write it like one. So this is how you would define and so forth. So this is a very rich text editing format. So you can actually document even with mathematical equations. You can actually document in these text cells. If you prefer, you don't want the particular, say for example, you added something here, and you also do Shift Enter. If you do not want this cell, so you can go here and delete that as well. So these are some essential things that I wanted to tell you. So Shift Enter is the important key to execute this. So you can press that, so it will execute those cells. So you can have any number of statements in a cell. So these are some essential introduction. So this by default is running on as a CPU in the cloud session. So what if you are using some, say for example, using computer vision based experiment. So you wanted to do some classification, computer image based classification or segmentation and so forth. And you have data set with you and you wanted to train it. So if you have access to GPU, then the training will be faster. So how to access the GPU in your Google Colab? So what you have to do is, at the top there is an option called runtime. So you click on that runtime, you go to the change runtime type. So you click on that. So here you have the option to take additional hardware accelerators. So the none means there is no additional hardware accelerators. So it is by default using the CPU. But if you wanted to use the GPU, the freely available GPUs, you can click on that. So there are two options, either to take the GPU or to take the TPU. The GPU is the graphical processing unit. TPU is the tensor processing unit, which is a bit more powerful architecture than GPU. This is designed by Google. The TPU is designed by Google. And if you have a huge data set to train, you can prefer taking TPU. If your image data set is not very huge, but it is reasonably sized, then you can consider taking GPU. So you can select that, say for example, GPU, and then you save it. So once you save it, what happens is it will again reconnect. So So it is again connecting, and now it will be connected with GPU as its background hardware engine. So just to make sure whether GPU is enabled or not, you can just place your mouse pointer on top of this. So it will tell you. So there is a small pop-up message. So there you can see it is started with GPU as the backend. So these are some essential, important things that will be useful for you. For even for later sessions, it will be useful for you. So now let us leave all these things. So let us come back to the data visualization part. So this is our important. So how we have got to this? So you have created a folder. You have uploaded the data visualization _lab file. So now you right click on it and you will be able to open it here. So now what I'm going to do is, so I have some outputs already shown here. So now what I'm going to do is I'm going to clear all these outputs. To clear all these outputs, what you have to do is go to this edit. So there is an option, clear all outputs. So I'm going to clear all the outputs. So I'm going to run each cells and I'm going to explain you what are those things individually means. Is there any doubt with opening this IPython notebook, whether anyone was able to open the IPython notebook in Google Colab? Did anyone tried it?
Yes, we have tried it and able to open it.
You're able to open it. Okay, thanks. Yeah, thanks for confirming. So now, since I'm not, this is just visualizing the data. So we are not going to run any intensive experiments with images. So we don't need access to GPU and so forth. So I'm not changing the runtime. So I'm just using the CPU. I don't want to unnecessarily use GPU here. So I don't want to set it there. So what we will do is let us connect to the Google Cloud session. So once we have opened it from this one, let us connect it to the Google Cloud. Sorry, was there any query? It was not clear to me. Sir, was there any?
Sir, can you repeat it? The steps how we go into this Colab, please.
Yeah, so see, the better, easier way now is that you create a folder in your Google Drive. I just named it as AMU. So just navigate inside that AMU, and then here what you have to do is you click on the upload files. So what you have to do is you have to navigate to where the IPython notebook is. So you have downloaded a zip file and extracted it. So you go inside that and you select the IPython notebook, and then you double click that, or you select that and you open it. So that will upload it here. The IPython file will be uploaded here. So once you have uploaded it, then you can, if the Google Colab is already installed, you can straight away double click it. That will also open it. If not, you can just go here, right click on this IPython notebook, you select the open with option. So there will be Google Colab. If it is not showing up, then you have to click on the connect and you have to install the Google Colab. So you just click on it. You can search for Colab. It's called Collaboratory. And then you have to install this Google Colab. So once you have installed it, so this all will happen very quickly. Once you have installed it, then you should be able to open it with Google Colab. So once you do that, it will open up in the immediate browser. As the next tab, it will open up. Is that clear? Or is there any further confusions with that?
Yes, sir. Yes, sir. Thank you.
It's clear. Okay. Let me see. Because since I am running all those presentations, I won't be able to quickly look at the chat window. So that is one additional challenge we have. But anyway, I think everything is fine as of now. Okay. If you have questions in between, I think it's better you interrupt and ask through voice, because if you type in, I won't be able to look at it. That's a challenge. Okay, so now once you have opened it, you click on the connect button and we let us connect it to the Google Colab. So once you see this green tick symbol, so that means Google Cloud session for Colab has been allocated to you. So now you can run experiments using the Google Colab environment. So what I have done is, this is just a text cell. So I have just put a single hash and I have just entered data visualization and use shift enter. So that's how this is like a top level heading. And then I have double hash. So this is my second level heading and so forth. So I'm just explaining. So you can also click here, it will fold that immediate following down. So anything under this will be grouped as one subsection sort of thing. So what we are going to do now is we need some data for us to visualize now. So let us download data now. So the data is already, I have uploaded it in the Vision Core website. So using this Linux command, we are going to download this particular data file. So when you click on this left panel, so here you can see we only have one folder which is called sample_data. That anyway comes as default with this. So it anyway comes as default. So we are not interested in that. So we needed to download a data folder from the Vision Core website. One additional thing to notice is that this entire Google Colab is working on a Linux server. So the cloud platform is running a Linux server. So in a IPython notebook coding cell, when you start with an exclamation mark, then we can actually execute Linux commands. So whatever you open a Linux terminal and execute the commands, you can execute that here inside the coding cell as well. The only important requirement is it should start with an exclamation mark. Then this is a Linux command called wget. So this is through terminal, you can provide a URL and download. So this is a download utility through terminal. So I'm just providing the zip files URL, and this is a zip file. So what these two statements are trying to do is it will download the zip file and it will extract it using the unzip command, since this is a zip file. So I'm unzipping it. This is also a Linux command, and I'm specifying which zip file I should unzip it. So that is the name, data.zip is the file that I need to unzip it. So these are two Linux commands that I am currently going to do. So let me just run it. So I can just press shift enter. So that is, so we should practice, instead of clicking here, we should practice the keyboard combination. So that is much faster. So what it has done is it has connected to the Vision Core website. It has downloaded data.zip and unzipped it. So when you look at on the left side, if you click on this refresh button, now you can see two more files has come up. So data.zip is the file which we have downloaded now. And after extracting it, we have a folder called data. So when I click on that, so here inside we can see many CSV files. So I have I used to keep this data.zip file because in a longer course which I conduct, so I will be making use of many of the other CSV files. But in today's session, we will just look at two particular CSV files and we will just try to visualize it. So we'll just explain some of the important visualization libraries. So if you do not want to see this output message, you can always go here and click on this cross button. It will just remove that display. And we are going to import some essential libraries. So NumPy is a very important library. So I just wanted to mention about this. We won't be using NumPy today, but I just wanted to highlight NumPy is another important library. It stands for numerical Python. And it is a usual scientific practice to import NumPy as NP. This NP is an alias name. So wherever below, when we write NP, it will be translated as NumPy. So this is called aliasing. And this is a usual practice. In many of the Python libraries, we will refer it with a short name. So NumPy as NP is the standard practice. So we are going to import Pandas library, which is the panel data structure, the most prominent data analytics library. So we will have a short name for Pandas as PT. And we will have to use Seaborn for the visualization. And for Seaborn, it is a usual practice to import it as SNS. And just to initialize all the internal settings of the Seaborn visualization library, we just run sns.set function. And Seaborn relies on matplotlib. So we, for many visualization, for some additional parameters, we will have to use matplotlib. So this is also a standard practice. Import matplotlib's pyplot. There is a module called pyplot defined inside matplotlib, and we are importing it as PLT. So these all are very standard practices. It's better not to change it. So we can actually give any name we want here, but it is better to follow the general conventions. So it's better to import NumPy as NP, pandas as PD, Seaborn as SNS, and matplotlib.pyplot as PLT. So this is only an initial learning curve. So once you are familiar with this, every time it will be easier for you to import all these libraries. So now what we are going to do is we are going to open the CSV file. So CSV stands for comma separated values. So this CSV file, so whatever inside this data, so we have so many CSV files. So these CSV files can be opened using the pandas library. So let me just, anyway, for example, the advertising. So this is one CSV file that we are going to open. So we can just simply double click it just to see how that CSV file looks like. It will open up in a new tab. So here we can see the first column is serial number. The second column corresponds to TV. The third one corresponds to radio, then newspaper, then sales. So what this CSV file essentially captures is that if you have a certain budget allocated to you and you are allowed to spend the budget on advertising in different media. And so say, for example, for a given budget, if you spend 230 units, so this can be in different scales, so it can be in thousands of dollars or rupees. So 230 times 1,000. So that is something different. So here we are just showing a scaled down version. So 230 has been spent on TV, 37.8 has been spent on radio, and 69.2 has been spent on newspaper. And how much sales that we encounter. So that is the information capture. So each row captures this information. If you spend this much of amount for TV, this much of amount for radio, and this much of amount for newspaper, how much is the sales that is achieved? So this is the CSV file we have it. So now what we are going to do is we are trying to understand about this data through the pandas. So let us close this CSV file. So let us know we don't want that. So what we are going to do is we are going to read the CSV file. So PD is our pandas library. So there is a function defined inside pandas, so you can access it using the dot operator. So that's what this dot here. So PD dot read CSV, and then you specify the CSV file path. So this advertising.csv is the file. This is present inside the data folder. So that's what we needed to specify, data / advertising.csv. So it will access data and the CSV file. So once it reads it, it will store it inside a variable. So we call that as df_advertisement. So whenever we are reading a CSV file, we have to keep in mind that it is reading it as one of its data structure called data frame. So we saw previously that pandas has two data structures called series and data frame. So when you do this read CSV, it will be opened and saved as a data frame. So just to address it as a data frame, I have mentioned it as DF. So in many standard documentations, you will see this something written as DF. So that means it stands for data frame, and it is related with the advertisement data. So once you execute it, you will have this data read. So all these data that we saw inside the CSV file, it will be read and stored inside this variable. And if you wanted to just look at what are the first 5 entries in this particular data frame, there is a built-in function called head. So access the data frame and then use .head function. It will print you the first 5. So let us execute this particular cell and see how it looks like. So now let us print. Okay, so so I haven't imported it, so I have to run this particular cell so that it will understand what is PD. So I didn't execute it. So if I have not executed it, you can see there is a blank. So here it is what it says 1. That means this cell is executed. So it will sequentially show the number. So here when it is null, it means that that cell was not executed. So let me execute that cell now. So now it will have a number. So now that is fine. So now let us get into this particular cell and now let us execute it. So now it has read the CSV file and it is showing the first 5 entries. So that is what by default the head will do. So it is now showing us the first 5 entries. So when we look at this CSV file here, so you can see TV, radio, newspaper, and sales. So that's what we are also seeing here. TV, radio, newspaper, and sales. So now we can see what do you mean by this unnamed :0. So when you look at the CSV file, this TV, radio, newspaper, and so forth, they are called a header of the CSV file. So what is the name for each column? So that is what we call it as header. So when we think in that line, we can see that for serial number, there is no header given here. It is blank. So when Pandas is reading such a CSV file where there is a blank for a corresponding column, it by default gives the name unnamed :0. If there are multiple columns with no name, then it will give unnamed 1, unnamed 2, and so forth. So that's what it means. This 0, 1, 2, 3, it corresponds to the row index. So for this row, the first row, the index starts with 0. The second one starts with index 1 and so forth. We can think of these column names as the column index. These indexes are non-numeric. So this is something we can think of it like very much equivalent to the dictionary data structure in Python. So in Python, the data structure which allows non-numeric indexing is called dictionary. So dictionary is a core part of Pandas data frame as well. So here when you just call head, you can look at 5 entries. If you want to look at more number of entries, you can specify n is equal to 10 inside the argument. Now it will show you 10 entries. So that's what. Say this is showing from the top. What if you wanted to look at the bottom 5 entries, so the last 5 entries, there is another function called tail. So when you execute it, so you can look at the last entries as well. So now you will get an idea that there are total 200 entries in this particular data frame. So you can see it's a well-structured tabular data that is showing up here. Within Pandas, there is a function called info. So when you execute that info, it will tell you that there are 200 entries. The index starts from 0 to 199. And there are 5 columns. So even when you look at the CSV file, you can see there are 5 columns. So that's what it is telling here. And what is the name for each of the column? The first column, it corresponded to serial number. Since in our CSV file it was blank, it has already inserted unnamed :0. There are 200 entries. It is 64-bit integer data type. The TV, radio, newspaper, and sales, when you look at here, they are float values. So it is interpreted as 64-bit float entries. So altogether, it says how many different data types are there. There are 4 entries with 64-bit float and 1 entry with 64-bit int. So that's what it says. So it altogether takes this much of memory. So this gives you a general information about this particular data frame. So this is a very useful information. And on top of that, there is another important inference called descriptive statistics. So you can access this data frame.describe. So that will give you this particular information. These count, mean, standard deviation, minimum, maximum. These are called descriptive statistics. So how many numbers? The total number of entries corresponding to TV, radio. So that is the total count. So out of these 200 entries, what is the average value for each of the columns? What is the standard deviation for all those 200 entries? What is the minimum value out of those 200 entries? So for corresponding to TV, the minimum value is 0.70. You can also see what is the maximum value, that is 296.4. These 25%, 50%, and 75%, they are called quartiles in statistics. This is called first quartile. This is 50% is called second quartile, and 75% is called third quartile. So there is a more familiar name for this second quartile, which is called median. So we already have heard about median. It means 50% of the data corresponding to TV is less than 149. So that's what this median means, otherwise also called as second quartile. So the first quartile means 25% of the data is less than 74. This third quartile means 75% of the data under TV is less than 218 and so forth. So these are very important information that you can gather from these descriptive statistics. The standard deviation essentially tells you spread. So if the spread value, standard deviation value is small, that means these data are very close to the mean. If the standard deviation value is high, that means these 200 data are a bit farther apart from the average value. So that's what the standard deviation. Just by looking at whether the standard deviation value is high or low, you get an idea whether they are dense, these points are dense, or whether they are sparse and so forth. And from here we can see that this unnamed zero is some redundant information. We don't need that serial number. Anyway, we already have an index associated with that. So you can straight away delete that unnamed zero. So from the advertisement data frame, let us drop the unnamed colon 0. So that is from the column. And when we say replace it, so when you drop it in place, that means the original data frame will be modified. And from that, this unnamed colon 0, that column will be deleted. So once we do that, then you can see that unnamed column 0 is removed. So we only have the essential aspects. Actually, this data set can be used for a regression analysis. I think, so we are not covering regression analysis now, but in the later sessions, you will be covering regression analysis. This particular data set can also be used to make a prediction. If you spend a certain amount of money for TV advertising, certain amount of money for radio, and certain amount for newspaper, using a machine learning model, you can predict how much sales we can expect using regression analysis. So this particular data set, this is, since you have 3 attributes, this is called multivariate data analysis. From this, you can actually do a multivariate regression analysis and make predictions of sales. So this is one example I wanted to show. As an additional exercise, you can also try out a classification-based data visualization, which is there in the bottom part, so that you can do it as an additional exercise. So what we are currently going to do is, from the pandas, there is a function called hist. So that is essentially capturing the histogram of all these data, all these attribute features, you can say, all these columns, TV, radio, newspaper, and sales. We can look at what is the histogram distribution of all those data. And this fixed size means how big your display should be. So when you say plt.show, it will display the histogram informations immediately below this cell. So here it is telling you for all those 200 entries of data corresponding to TV, what are the various distribution of the TV values. You can see on the x-axis it comes up to 300. When you go to the descriptive statistics, you can see the maximum value is 296. So that's why the x corresponds to something close to 296. Here we have given bin size as 10. So the entire value from 0.7 till 296 will be divided into 10 different bins. So that's what you are looking at, 10 different bars. So here you can even change it. Say for example here, instead if I give 25 and then I run it, so then you will see very dense, very small bars here, because you have increased the number of bins. So it is trying to put all those under those ranges. So these are the distributions for TV, radio, newspaper, and sales. So you can look at these distributions. It's a very useful information. If you wanted to look at a scatter plot, okay, how the data corresponding to TV and sales are distributed. So you can also look at a scatter plot. So sorry, any question?
Sir, kindly repeat that plotting, please.
So here we are calling the histogram plot for all the columns present in advertisement.data. So we specify how many bins we need in a histogram. And then we specify the fixed size. The fixed size essentially captures this display here. So how much size it should be. So if I say, for example, reduce it to 5,6 and I run it, the image will be very small. See, it will be very small. So that's what we are actually controlling there. Is that clear?
Yes, sir. Thank you.
Okay, fine. So there you can specify the bins. If you wanted to find out, okay, between TV and sales, how those data are distributed. So we can just plot it with the kind scatter, and what you are looking at here is how between TV and sales those points are distributed. So here you can see the distribution between TV and sales. Here we can see there are some data which is overlapping. If you wanted to actually look at how many of the points are overlapping and how many are non-overlapping, there is an additional argument called alpha, which defines the transparency. So let us run it with alpha. What it does is that if there are more data overlapping, it will become a bit darker, others will be light. So that's what this alpha transparency is trying to do. So it is between X and Y. So you are specifying a scatter plot. We can, for example, we can plot for the entire advertisement. We can also specify that scatter plot, as well as we can combine the histogram in a single image. So that particular functionality is called scatter matrix. So that is defined inside Pandas plotting module. So from pandas.plotting, we can import this scatter matrix, and using the scatter matrix function, you pass the data frame that you wanted to look at. So it will give you a very beautiful description about visually. You can look at the data distributions. See what it is. This plot, what it is actually capturing is the correlation between two variables. How correlated two variables are. So TV and TV, between the same variables, we don't usually estimate the correlation. So that's why all the diagonals, so we have the histograms, and for the non-diagonal elements, we have sort of a correlation distribution plot. The same thing, the correlation distribution can also be captured as a matrix. So when you have a data frame, there is a function called correlate, CORR, which essentially stands for correlation. And by default, you can see here, by default, it is using Carl-Pearson correlation coefficient, and based on which you can estimate a correlation matrix here. So this is the correlation matrix. So this is the thing that is actually seen as a visualization, but this visualization has been sort of quantified here. Just by looking at these correlations, so let us try to understand how sales is related, influenced by different advertising media. Just by looking at this correlation matrix, you can see the correlation between TV and sales is 0.78. The correlation between radio and sales is 0.57. When you look at which one has got the highest correlation, we have to discard these diagonal elements. This one, say, correlation between sales and sales is not something we are interested in. But if you look at the other elements, we can see the TV and sales has got the maximum correlation. So just by looking at this, we can sort of tell that if you advertise in TV, the sales will increase. So that's what the sort of interpretation that you can get from these data. So even though these are some visualizations that is already inbuilt in pandas, we can also do visualization using the seaborn. So let us generate a joint plot. So the seaborn library is imported as SNS, so that is the alias name. So there is a function called joint plot. So what I have shown here is all some important visualizations that you will quite often need. So I have included all those. There are a lot of visualizations that you can do, but I am just in this lecture I am only highlighting some important visualizations that we regularly use. Even in our company we use it quite often. So that's what I am highlighting here. So we can have a joint plot between the TV and sales. So we can access a particular column from the advertisement data frame, can specify TV, and from the advertisement data frame we are accessing the sales, and then we are plotting it as X and Y axis. And so when we look at that joint plot, so you can see this is the distribution, the correlation distribution between TV and sales. This is what exactly we saw previously here as well, using the plot functionality in pandas. But with seaborn, you get a bit more interesting visualization. So you are not only getting these points, but for TV, what is the distribution, the histogram distribution, and for sales, what is the histogram distribution. So that is also plotted together with this visualization. So this is for the histogram. These histograms, so whatever histograms you are seeing here, we can approximate these histograms using a curve. And approximating all the histograms using a curve. So for this particular one, you can think of like some approximation like a Gaussian curve that you can think of it. So approximating that curve on top of this histogram is called kernel density estimation, which is popularly known as KDE. So to look at the kernel density estimation, what we have to do is when we are generating this joint plot, by default it is looking at histograms, but if you wanted a kernel density estimate, you have to specify what is the kind, and specify the kind as kernel density estimate. And now you can see here, so it is trying to approximate with curve. So here we had the histograms, but here you can see it is trying to approximate with the curve here. You can also generate a regression plot. So regression is not mostly the regression when you interpret it geometrically, it is trying to find out a best fitting geometry for the points. So when we look at the TV and sales, it is sort of a linear distribution that we have. So let us generate a regression plot for TV and sales. You can see that we are trying to fit this distribution plot using a straight line. So for a linear data, yes?
Sorry to disturb you, sir. Sir, there is a blurred area near the line, I mean, the fitted line. Can you explain what that blurred area is?
Where? This one? Which place?
Yeah, right now, the image you are explaining, that regression part.
The regression part here.
Here you have plotted that line. I think that is the best fit line. But nearby there is blurred area as well, bluish area.
This one here, right? So it is just, yeah, it is plot. It is just showing the error estimate, the error estimation of this particular straight line. So when we do this regression plot, what it will do is that it will just internally look at what is the error in representing those points by this particular straight line. It will show you a small error margin when we are drawing a
Hello, sir. Hello, sir. Is it the
yes.
conference band? You're talking about the error bar means the conference band?
Yes, correct. Yes. So
okay.
We can essentially think of it like it is capturing the error margin. So what is the sort of error in representing those? So it is not going to show for all the points. It will just show you some small that confidence band as you are mentioning. That's correct.
Sir, there is one more thing that many times we have multi-dimensional data, and it is
Correct.
difficult to identify how, I mean, how things are changing between those attributes together. Because usually we use 2D plot or 3D plot. So in that case, if we have, let's say, 4 attributes and 5 attributes, what do you suggest? What is the best way of representing the relationship among them?
See, if you wanted to just only visualize it, you can do manifold-based dimensionality reduction. And one of the best method is called T stochastic neighborhood embedding, TSNE. So we can use TSNE for that visualization. You can reduce the number of dimensions. If you have 5 or 6 dimensional data, you can reduce it to 2 dimension, and then you can visualize it. And when you reduce the dimension, you no longer have the feature names. The feature names disappears. So you cannot access it with TV and sales anymore when you reduce the number of dimensions.
Sir,
But
is it PCA?
not clear.
Sir, is it the method you have mentioned for dimensionally reduction, is it similar to PCA?
Yeah, so PCA, yeah, it is not exactly similar to PCA. PCA is a statistical approach of reducing the number of dimensions, principal component analysis. It essentially looks at what is the eigenvalue and eigenvector along each of the dimensions, and it projects it. So it is a projection-based approach, what we do for PCA. So the exact visualization, we can also do it with PCA. So for the visualization part, TSNE is the most popular approach to reduce the number of dimensions. And that is a probabilistic approach, the TSNE.
Thank you.
Is that clear? Yeah. So we can reduce the dimensions using either projection-based approach, or we can also reduce it using manifold-based approach. And the most prominent approach for projection is called PCA, principal component analysis, and the most prominent in manifold approach is TSNE. Yes? Okay. So here, the similar, yes, any question?
No, sir, no question.
Okay, fine. Yeah, so similarly, like what we obtained using pandas, so we can also obtain a pair plot using Seaborn as well. So it will also show you along the diagonals, the distribution, histogram distribution, and along the non-diagonal elements, it is showing the correlation plot. So from this, you can, if the plot is more skewed, so here you can see they are more distributed, but if they are more skewed, that means these two are exhibiting better correlation. So when you look at this between TV and sales, the data is more skewed as compared to radio and sales or newspaper and sales. So this is what we are interpreting, that if you advertise on TV, that has a good correlation with the sales. So if you spend more money on TV, you can expect more sales. That is what we visually try to understand from this particular distribution. And whatever so far the advertising.csv, it is more related with the regression data set. I have also given another example where you are dealing with a classification data set. So one of the major difference between regression and classification is that if the prediction is a continuous value, for example, the sales is going to be a continuous value, then we call that as a regression. But if your output is limited within a finite number of output values, then they are called classification problems.
Sir, there are some questions coming, and it is almost the end of the session. Can we take those questions?
Yes, right. So just one more thing. So what I have mentioned is, so here I have introduced about the iris, which is a classification based data structure, and I have given some plots, this KDA pair plot and so forth. This as an exercise, you can try it out. So now we can take up the questions, so whatever questions you want.
Okay. Sir, one question is how we can use the describe function for string variables.
Okay. So let us so here when we straight away use the describe, it will only show us the numeric entries. This particular describe will show us only the numeric entries. In this particular data frame, we didn't had any string variable, so that was fine. Say, for example, when I open this iris.csv file here, so here it is one of the most popular data set, iris flower classification. So based on sepal length, sepal width, petal length, and petal width, we needed to find which type of flower it is. Within iris, there are three categories: setosa, then virginica, and versicolor. So there are three types of flowers. So now this is non-numeric. So when we do a describe, it will not show up. So let us just go there. Let us run this iris flower. Let us load this. So here, this is the last column. It is non-numeric. So when we look at the info, it will show it as object. So whenever it is non-numeric, it will represent it as object. Otherwise, it will say whether it is 64-bit float or 64-bit int and so forth. When we look at the describe, now it is only showing for numeric entries: sepal length, sepal width, petal length, petal width. So it doesn't. So when it is, say for example, non-numeric, like these strings, setos or categories, we cannot actually mention anything like minimum, maximum, or these sort of quartile, interquartile statistics cannot be mentioned. So to do that, so there is something. So let us enter another one, and here there is an option called include. So you specify include, and then you say what is the name here. For the column, it is species. So now let us say we need to include species. So there is a function called include, so we can specify access it using include. So let me see why it is not showing up. So there is a species, so there is an option called include. Data type species not understood. So let us just search it. So I think maybe the syntax is not correct. So let me just see.
It's 11:30 now.
Okay. Yeah. So pandas describe. So let us just say include example. So this is where we have to mention it, include. So that I don't understand why that include is not showing up here. So here when we say include all, so let us say include object. So now it is showing about the species here. So what we have to give is it's the object data type that we have to specify. When we say object, then it says corresponding to species. There are totally 150. There are 3 types, and virginica appeared maximum number of times. And how many times it appeared? It appeared 50 times. So that's what it essentially tells you, the essential descriptive statistics. And if you specify all, I think it will now even tell according to species. So wherever there are no appropriate entries for unique top, it will include not a number. So I think that answers your question. Any other?
Thank
Any
you, Ram.
other question?
Here is Dr. Faisal Anwar from one of the coordinators.
Sorry.
Sir, it was very informative and valuable session for all of us. No, it's we have to start next session after an hour. So very thank you again. We all are very grateful to you. So participants, now we will meet again at 12 for the next session. So you may leave this session and try to log in before 5 minutes to 12.
Yes, sure.
Sir, some
Okay.
participants are requesting for your contact numbers. So could you please share your contact numbers?
Yes. So
You can
just
share it
type.
on chat box.
Yeah, okay. So it's 7356135445. Mail ID is ram.krish@visioncorp.com. And from the slides that you have downloaded already today.
Yes, sir. We have
so
the slide.
In the slide, at least the data visualization part, I have already mentioned my email ID and my WhatsApp contact number. So that is my WhatsApp number as well. So,
thank you, Ramasas. We will again meet, and we have one more session with you. So we will again meet
on 30th. Yeah. So we have a discussion
on
business intelligence. Okay.
Yes.
Okay. Thank you. Thank you very much. All the best. All the best.
Thank you. Thank you so much.
Okay.
Participants, you may leave this session and try to log in for the next session again. Thank you so much.
So this IPython file is already available in the download. So
yes,
so you can always access it. So somebody was asking that about IPython notebook. So it's already there in the
in that file.
Yes. Download. Yes, correct. Okay, thank you very much.
Thank you.